Antarctica, a land of breathtaking scale, a continent sculpted by ice and time. It is a place of stark beauty, seemingly remote. Yet this frozen southern realm is deeply connected to us all. But today, in May 2025, this icy giant is stirring. It faces an unprecedented crisis, a period of rapid change. The delicate balance that has defined Antarctica is now under threat. Ice, the very essence of Antarctica, is disappearing at an alarming rate. The land itself is transforming as plant life begins to spread. The surrounding sea ice, a crucial shield, is shrinking. This continent is warming and doing so quickly. Indeed, parts of Antarctica are warming twice as fast as the global average. Antarctica is a key regulator of our planet's climate. Its immense ice sheets store the majority of Earth's fresh water. Its health directly influences global sea levels and weather patterns. What happens in Antarctica does not stay in Antarctica. Let us explore the challenges it faces. When we think of Antarctic ice loss, grand spectacles often come to mind. Huge icebergs the size of cities or even small countries breaking free. Events like the carving of A68 in 2017 are truly awesome. They capture headlines and our collective imagination. However, these massive, infrequent events are not always directly tied to climate change. The more insidious threat comes from a different kind of loss. It is a quieter, more persistent erosion of the ice. A steady drip rather than a sudden flood. The real concern for climate-driven mass loss is something else. It is the increasing number of smaller carving events. Think of it as a death by 1,000 cuts. Each individual event might seem minor on its own, but taken together their cumulative impact is enormous. These smaller losses are happening more frequently. They are a direct response to the warming environment. Antarctica is often pictured as an endless expanse of white, a world almost devoid of visible plant life locked in ice. But even here, life finds a way, clinging to the fringes, and now parts of this white continent are slowly turning green. This phenomenon is most pronounced on the Antarctic Peninsula. This is the northernmost part of the mainland, stretching towards South America. It is one of the fastest warming regions on Earth. What we are witnessing is a significant ecological shift, a visible response to a rapidly changing climate. The increase in plant cover, primarily hardy mosses, is striking. Over the last 3.5 decades, from 1986 to 2021, plant cover on the peninsula has increased nearly 12-fold. The primary driver behind this Antarctic greening is clear. It is the rising temperatures experienced in the region. As the climate warms, more ice-free areas become available. The growing season for these hardy plants becomes longer. This greening, while perhaps appearing benign, has consequences. Section 4. Vanishing shields. The alarming decline of Antarctic sea ice. Beyond the vast land-based ice sheets, Antarctica has another icy cloak. This is its sea ice, a frozen expanse of ocean water. Unlike Arctic sea ice, which is largely enclosed by land, Antarctic sea ice forms in the open ocean surrounding the continent. This means it can expand further in winter, but it also means it can melt more readily in summer. This sea ice plays a vital role in the Earth's climate system. It acts like a vast reflective mirror in the Southern Ocean. Its presence helps to keep the polar regions cool. However, this crucial shield of sea ice has been shrinking. Since 2014, we have observed a worrying trend of decline. Antarctic sea ice extent has hit consistent record lows. This is a departure from previous decades when it showed more stability or even slight growth. The reasons for this recent rapid decline are still being intensely studied, but the pattern is clear and the implications are serious. The loss of this reflective surface is a key concern. Section 5. On the precipice. Antarctica's potential tipping points. The concept of a tipping point in climate science is crucial. It refers to a threshold beyond which a small change can lead to dramatic, often irreversible consequences. Imagine a canoe leaned too far and it capsizes. Earth's climate system, like Antarctica's ice, may have such tipping points. Once crossed, the system could shift into a new state, a state from which it is very difficult to return. Record lows in Antarctic sea ice since 2014 have raised alarms. Some scientists suggest a tipping point may be near. The patterns are consistent with what we might expect near such a threshold. The sea ice system is less resilient to disturbances. Section 6. The global conveyor belt: melting ice and ocean currents. Our planet's oceans are not static bodies of water. They are in constant motion, driven by a network of powerful currents. This system, often called the global ocean conveyor belt or thermohaline circulation, is vital. It transports heat, salt, nutrients, and dissolved gases around the world. It plays a fundamental role in regulating Earth's climate. It influences weather patterns from the tropics to the poles. Antarctica is a key engine room for part of this global circulation. What happens to its ice and surrounding waters can affect the entire system. A crucial component of this system is Antarctic bottom water, or AABW. This is extremely cold, dense, salty water that forms around Antarctica. As sea ice forms, it rejects salt into the surrounding water. This makes the water saltier and therefore denser. Being very cold and dense, this water sinks to the deep ocean floor. It then spreads slowly northwards, carrying oxygen and nutrients. AABW is a significant driver of deep ocean circulation globally. Section 7. Eyes on the ice: the critical need for advanced monitoring and action. To understand the profound changes sweeping across Antarctica, we need clear vision. We must observe, measure, and interpret what is happening. Understanding past changes is crucial for context. Knowing the current state of the ice is essential for assessing risks. This requires robust data gathered consistently over time. Only with this information can we grasp the scale of the challenge, and only then can we make informed decisions. The future of this great white continent hangs in the balance. Our ability to monitor it effectively is paramount. Fortunately, we have sophisticated tools and methods. Satellite imagery has been a game changer since the late 1970s. It provides a continuous eye in the sky, tracking ice extent and movement. Remote sensing technologies measure ice thickness and volume. Advanced computer models simulate ice sheet behavior. They project future changes under different climate scenarios. Historical data from old ship logbooks or ice cores provides a baseline. These diverse sources of information are pieced together by scientists.